Hello students, today we will do one question. The question states, consider three charges Q1, Q2 and Q3 each equal to Q are placed at the vertices of an equilateral triangle of side L. What is the force on the charge Q with the same sign as small q placed at the centroid of the triangle? So first things we need to know is that we are given three charges. We have given three charges Q1, Q2 and Q3 which are equal to each other and have a magnitude equal to Q. And then we have given one more charge capital Q which have same polarity as small q. Now what is the position of the small q and the capital Q is that small q are placed at the vertices of an equilateral triangle. And charge capital Q is placed on the centroid. Centroid implies center of triangle. Okay. So now let us understand what is an equilateral triangle. Equilateral, as the name suggests, equi means equal and lateral means sides. A triangle having all the three sides equal to each other is called equilateral triangle, and in this case the length of the side is L, small l. Okay. The other property of an equilateral triangle is it have same angle. So what is the sum of all the angles of a triangle? It is theta 1 plus theta 2 plus theta 3 equals to 180 degrees. So all these theta 1 equals to theta 2 equals to theta 3 equals to theta. So theta plus theta, how much will it be? 3 theta equals to 180 degree, and hence theta comes around 60 degree. So what is the angle of this triangle? It is 60 degrees. What is the length? It is L. Okay. Now see what is given. Given is side of equilateral triangle is L. Charged placed at each vertices of the triangle are Q1 equal to Q2 equal to Q3 equals to Q. Now let us see this diagram of triangle and let's try to understand the situation. Here at A we have placed charge Q1 which is equal to Q. At B we have placed charge Q2 equals to Q, and at C we have placed charge Q3. These are the vertices. The corner ends of the sides of a triangle are known as vertices. On the vertices we have small q, small Q1, Q2, Q3. Fine. Now see this point here at the center of the triangle. It's not exactly like with the pen and pencil we cannot draw. It's drawn with the help of the angles, bisectors. So this is center of the triangle known as centroid. Okay. So at this point we have placed what charge? Capital Q. What is the property of capital Q? Capital Q have same polarity as the small q. If small q is negative, then what will be the capital Q? It will also be negative. If small q is positive, what will be capital Q? It will also be positive. Okay. So what we have is always, unlike charges attract and like charges repel. So what kind of attraction we will see here? We will see what kind of force we will see here. We will see the force of repulsion in this system. Now We will draw one perpendicular bisector on BC from A. This is our A. From here we are drawing this line, C over here, to D. Okay, this is perpendicular to BC, this length. This is perpendicular to BC. So using this perpendicular bisector, we have to find the length of AO, BO and CO. As our triangle is equilateral, these three sides will ultimately be equal. As our triangle is equilateral, these sides are also equal because we are measuring the distance from the center to the vertices. So as it is given, our triangle is equilateral, hence these will also be equal. So now let us take the case here. We will use Pythagoras theorem. To find the various values. First of all, we will find the value of AD. For that, see the diagram, we have taken this one. Here, what is it? A, D and this is B. So, according to Pythagoras theorem, hypotenuse square equals to base square plus perpendicular square. Okay. What is the value of hypotenuse? It is L square. What is the value of base square? It is the half of the total base. Total base is L and half of L is L by 2 and that needs to be squared. And what is the perpendicular's value? It is AD, which is unknown to us, AD square. So it will become L equals to L square by 4 plus AD the whole square. And from here we will find that AD equals to under root 3 by 2L. So this is the value of AD. Now we will take another triangle over here. Like this one. This is our 90 degree. This is our 90 degree. As I said, it is a perpendicular bisector. And this will be our 30 degree as this is bisector. Bisector divides the angle into two equal halves. This will also be 30 degree. So using the trigonometric formula over here, we will try to find out the value of, this is O, this is B, this is C. Okay, the value of either OB or OC, anything, because all these three values are equal. So if we find one, we will be able to find all the three. So using this one trigonometric formula, we will take sine 30 degree equals to perpendicular upon hypotenuse. But here we do not know the value of perpendicular OD. So we will turn to some other formula. The other one is cos 30 equals to base upon hypotenuse. What is the value of base? L by 2. So we can use this formula of cos. Okay, this is how we select the trigonometric formula. So cos 30 is under root 3 by 2 equals to, what is the value of base? L by 2 upon hypotenuse. The value of hypotenuse we need to find. Then h equals to L by 2 divided by under root by 2 and it will come L by under root 3. So what is the value of AO? BO and CO is under root 3 upon 4. Under root 3 upon 4 L. No, under root 3 L upon under root 3 is the value. Here it is the mispronunciation. Kindly correct it. The value is this one. See over here. L upon root 3. I'll mark it with the red ink. So it is equals to L upon root 3. We will be substituting this value to find the force using Coulomb's law. Okay, so let AD be a perpendicular to side BC. AD equals to AC cos 30, and it will come around AD the whole length, okay, not from O to D. AD, which we have found using Pythagoras theorem, are same. Using trigonometry and Pythagoras, they are same. Here what we have used, we have trigonometric formula, and what I have did is Pythagoras theorem. So using both the things, we have learned how to find the length of our altitude. Okay, so these both the formulas are very much important. Know how we can use Pythagoras theorem as well as the trigonometric formula. And by using the for the second time, we use the trigonometric formula to find the length from A to O, B to O, and C to O. At O, what we have? At O, we have capital Q charge, on which we have to find the force due to Q1, Q2, Q3. Now, see over here, O is the centroid of the equilateral triangle that we know, and we have found the value of OA, OB, and OC. Distance of OA is 2 by 3 AD, 2 by 3 times AD. Now let's find out. What we have found, the value of this is L by under root 3. Okay, now from this formula, let's try to find out how it will come. They are saying that AO equals to 2 by 3 AD. What is the value of AD? It is under root 3 by 4. So into 2 by 3 into under root 3 by 2L. This will get cancelled out, and this 3 can be written as under root 3L upon under root 3 into under root 3. 1 under root 3 will cancel out, and the resultant answer is L upon under root 3. So using the trigonometric formula, we got this, and using the triangle formula, we got this one. This is actually a universal fact when we are dealing with the equilateral triangles. In any equilateral triangle, from one vertices to the centroid, that distance is equal to 2 by 3 times the whole distance from vertices to the end of perpendicular. Okay, so this is universally facted thing, and we have similarly found L by under root 3 as AO, BO, and CO. See here, by symmetry we have this because we are dealing with an equilateral triangle. Now we will try to find out the force. Okay, first of all, we will find the force between these two charges, Q2, Q1, and Q1, Q3, and Q2, Q3. Okay, so it will be same for everyone. F equals to Q1, Q2 equals to F Q2, Q3 equals to F Q3, Q1. K into the respective charge Q1, Q2, or as the charge is same, Q1 equals to Q2 equals to Q3, we will take it as Q square. Okay, we will take it as Q square upon K into Q square upon L square. L is the length of side of equilateral triangle. Okay, so it will be same for all, like from here, here, and here. Every force is same, but we have to find out what is the force over this point. Okay, now moving on the first point, force F1 on capital Q due to small q, which is present at A, position A, 1 by 4 pi epsilon naught, that is the value of K, into capital Q into small q divided by the length between them. What is the length between them? L by under root 3 is the length between them. It is the AO, distance AO, that will be squared up, and we will get 3 by 4 pi epsilon naught into q by L square. One is capital Q, other one is the small q. Okay, q by L square, this will be alone AO. So see here, again I am making the triangle. This is A, C, B, and this is our bisector D. So, and this is our O. So what they are saying, the charge is in direction of AO. AO implies this direction. Okay. Second question, second statement, F2 on capital Q due to small q, which is present at B, is given by 1 by 4 pi epsilon naught into capital Q into small q divided by 1 by under root 3 into L the whole square. Same, we will get the same expression, but only there will be a change in direction. Now the force is in direction of from B to O, from B to O. Similarly, F3 on capital Q due to the small q, which is present at C, will be given 1 by 4 pi epsilon naught into capital Q small q divided by L square by 3, and we will get this value, but again it will also be in the direction of C to O. Okay, now we have got the force in 3 different directions. Now it is very much important to use parallelogram law of vector addition. Parallelogram law of vector addition to understand how these will be added up. Okay, so in this case we will have resultant of forces F2 and F3 is 3 by 4 pi epsilon naught q by L square alone OA. So see this, I'll take the other pen, see the blue ink where it is going. For this one and this one, resultant will come in between here. Okay, resultant will come here, and this resultant is opposite to the resultant of AO. Resultant from BO and CO will be alone OA, from O to A. And what is the direction of force? Direction of force due to Q at A on capital Q, it is AO. So see, we have opposition in the direction are opposite by 180 degree. So using again vector law of addition, what we will get, the Coulomb's force will become like 1 by 4 pi epsilon naught into capital Q small q by r square, and then we have unit vector alone AOA plus unit vector alone AO. Now unit vector alone AO equals to unit vector alone AO in the minus format. So we will substitute this value over here, and we will get this value will change as OA minus cap OA. So what is it? It's 0. So something, the direction comes to be 0, the unit vector turned into 0, and hence the total force on capital Q turns out to be 0. Something multiplied with 0 is 0. So the whole system 1 by 4 pi epsilon naught into capital Q small q divided by L square into 0 will turn into 0. So the force on capital Q, which is placed on the centroid due to the small q's placed on the vertices of an equilateral triangle comes around to be 0. Why? Because we have found out the resultant BOCO, which is from O to A, and the force on capital Q from the small q which is placed on vertices A is from from A to O, which have the directional component in the opposite direction, and when we summed up the two forces in opposite direction, they cancelled out each other, and hence the force is 0. I hope you have got a clear idea how we solve this question. So bye bye for this time. We'll meet in the next class.